Write the new question for today's class. Implement. The question for today's class is implement design a Mealy state machine using JK flip-flop. So when you have your question of this state diagram, which is having 4 states, so the same way you can have any other problem of state machine with any other type of state diagram. First step is getting your state diagram proper. After that, you have to make your state table. The first table what you make is state table. There is no change in this with respect to any flip-flop. The state table remains same for any flip-flop design. So when you are writing this state table, it is in variable form. Present state as well as next state is in variable form. And when we see that we have 4 variable, we understand that 2 bits are good enough to define these 4 variable. So when I have 2 bits, those 2 bits is 2 to the power 2, that is 4 states it can take care. So as we did for D flip-flop, it is same here also. The present state A, B, C, D are named as A as 0, 0, and then we call it as FA and FB. A as 0, 0, B as 0, 1, C as 1, 1, and D as 1, 0. So state table does not change with any flip-flop implementation. State transition table also does not change, because state transition table does only the job of converting the state variable alphabet name to state variable bit value, binary name. Because any digital machine will not understand ABCD. Digital machine will understand zeros and 1 only. So we denote state A as 0, 0, state B as 0, 1, state C as 1, 1, and state D as 1, 0. Again, I would like to repeat that I have made state C as 1, 1 and state D as 1, 0. There is no compulsion here. You can design whatever you like. You could have made state C as 1, 0 and state 4 also as 1, 1. Only the final circuit will change, but the working will not change. Okay, so we are in habit of doing like this, so we have done. So your state transition table does not change even if you are trying to implement it using any other flip-flop. Now, after the state transition table, next is our excitation table. Here, this excitation table is for D flip-flop. Only the change happens or the change starts from the excitation table only. So now we have to see the excitation table of JK flip-flop for this problem. Okay, so this is our today's work. So let us directly start with the excitation table. So today is I hope you would have made the skeleton of the table at least.
Yes, ma'am.
If somebody has not made, do it fast. Okay. So now what we are doing is we need to make excitation table for the given state machine using JK flip-flop. And you know, as we were using the application table of D flip-flop, same way we need to use application table of JK flip-flop. So I will write for my reference the application table here. So if my present state is Q and next state is Q plus, I need to see all the possible transition. First one is 0 to 0, 0 to 1, 1 to 0, and 1 to 1. This means what? This is your application table, or we also call it as excitation table. So this shows that if my flip-flop output is changing the state from Q to Q plus, what should be the excitation input? So you all know that when we change the state from 0 to 0, there are 2 possibilities. One can be that it is a memory state with 0 and 0. Other one is it can be a reset state with J and K as 0 and 1, right? So 0 and 1 is also there, 0 and 0 is also there. So this becomes a don't care. So it is 0 and don't care. Now, when other possibility was 0 to 1, it can be Toggle
One
state,
don't care.
correct. Toggle and as well as set. So one don't care. So next is 1 to 0 is again a toggle is possible or a reset is possible. So it is
Don't
don't
care
care
one.
and 1. Good. Now next is 1 to 1.
Don't care zero
Yes,
one.
correct. One memory possibility is there and other one is set possibility is there. So we have don't care 0. So if you make this application table for reference, it will be easy for you to do in exam also. Okay. Now let us start making our actual excitation table. Now present state I am copying here, which is called as FA and FB. So I will have my all the 4 rows here ready with me. Okay, and then I need to make the rest of it. So this is my present state. Next state is input xy and output as 0, right? So when my input when my input is 0 0, of course I have my this table with me. Okay, I have this table with me. Now what you see here is fa plus. To get my fa plus, here I need the flip flop which will be jaka input. Okay, now for fb plus I will have my other flip flop which will be jbkb input. So I will require again my 2jk flip flop. So for under 0 0, for FA, yesterday we saw only DA and DB was there. Why? Because it was a single input flip flop. But now JK is a 2 input flip flop. So for FA plus, that is your Q plus actually. For this Q plus, you will have input of JAKA. For FB plus, you will have input of JBKB, and this will repeat for all the 4 columns. So you will have a very big table. Okay, so now let us start with that. For your 0 and 0, I will have JAKA, that is my one flip flop. JBKB, that will be my next flip flop, and Z is my output for this 0 0 input possibility. Same way I will have for 0 1, and I will have for JAKA, JBKB and Z. And like this I will have to manage space for other 2 also. Okay, now so for 0 0 done, 1 1 and 1 0. So I will have my JAKA, JBKB, right? Next I will have again my JAKA, JBKB. Okay, now let us start. So what we have to see is how the change is happening. 0 to 0. Okay, 0 to 0 in application table you see that it is 0 and don't care, right? 0 to 0 is 0 and don't care. So if I want my FAQ to become Q plus 0, J and KA is 0 and don't care. So how do we write? We write here for JAKA 0 and don't care. Do you understand this? Your present state is written here, but instead of your output you are writing now excitation input. So my output is fa, so you should keep one finger on fa column, other finger on fa plus column, and seeing this 0 to 0, 0 to 0, 1 to 0, 1 to 0, seeing this you have to write your excitation input. So now I will keep my hard copy with me, and you people have your notes copy with you, right? So now you do that with me. you keep your one finger on the FA column, other finger on FA plus column, and now you start dictating me what will happen. Okay, so number 1 is your JAKA for the 0 0 column. So now tell me 0 to 0, next again it will be a 0 and don't care, right? What is the next one? What is the next one? It is
Don't care and 1, ma'am.
right. 1 to 0, so don't care and 1. Again 1 to 0, so don't care and 1. So we will have to write like that only. So don't care 1, don't care 1. Now we have to see FB to FB plus. FB to FB plus. If you see here, FB to FB plus. So 0 to 0, 1 to 1, 1 to 0, 0 to 0. So these 4 things we have, and for that we have to do here now. So first one is 0 and don't care, right?
Yes,
If I do any mistake, please let me know. Next one is don't care and
0.
0. Third one is
Don't care 1.
correct. Last one is same as the first one, that is
0
0
don't care.
and don't care. And if you remember very well from yesterday's problem, that Z is 0 for all of it, except in the third column, last one is a 1. So let me complete the Z part here. So this is your Z part. Okay. Now, anyone should dictate me the rest of the JA and KA. Yes, who will do it? For 0, 1 column. What you have to do now? You have to keep your finger on FA here and FA plus here, right? FA of 0, 1, sorry, FA of present state and FA plus of 0, 1. So now how is the transition now? 0 to 0, 0 to 1, 1 to 1, 1 to 1. So these are the 4 transition which we have to write in the excitation input. So start, tell me.
Ma'am, 0 don't care.
0 don't care.
1 don't care.
1 don't care.
Don't care 0, don't care 0.
Correct. I hope you people are understanding now. Same way for JBKB, you should tell me now.
Ma'am,
Yes.
0 don't care.
Yes.
Don't care 0.
Correct.
Don't care 1.
Correct.
0 don't care.
0 don't care. Correct. So like this you have to fill. So shall we fill complete and proceed, or you people can do it on your own now?
Ma'am, will do it now.
Okay. Okay, so for the interest of all, let me just write a few things which you can do later then. Please check if I am doing all the transitions correctly. Okay, for JA and KA of the last column, it is. So this is the excitation tables, and in your exam, each table will carry some 3 marks. Okay, so it is stepwise marks, no, you know that. So each table will carry, you should write each one very clearly so that examiner finds things easily and give you marks accordingly. Okay, now what is the next step? Can anybody tell me? We have to, yes,
JA, KA, JB, KB.
yes. So now your JA, KA, JB, KB, all are function of FA, FB, X and Y. And you know that this has FA as MSB and Y as LSB. If you do ulta here, all K-map will become opposite and answer will be wrong. So you cannot afford to do that. Okay. So writing these equation in min-term form is next challenge that you have to do it correctly. So what you have to do is, now I have to see JA is 1 for which all term. JA is 1 for which all term. Okay. So now when you see that there are how many ones in JA? You can see one here, right? Another one you can see here, right?
Only two ones, ma'am.
Yeah, only two ones. Now we have to see which one is one. So when you see one here, what you see? 0, 1, 0, 1. So 0, 1, 0, 1 is what? It is a 5, right? Next what you have? You
Zero
have
one
your,
one one.
so next one is 0, triple 1. 0, triple 1. So 0, triple 1, where it is? It is,
Seven, ma'am.
yeah, it is 7 and it is here. You can see my mouse where it is. So it is 0, 1 here and double 1 here. So 0, triple 1 is for this one. I will mark it also here. This is 0, triple 1 and your 0, 1, 0, 1 is here. Okay, I have marked both. So we have minterm 5 and 7 here. But don't care is a big list. Don't care is a big list. I am writing here. You can verify it at a later time on your own. So don't care is 8, 9, 10, 11, 12, 13, 14, 15. So big is your don't care term. Okay. Now KA. KA is how many ones are there in KA? How many ones are there in
Four, ma'am.
4 ones? So now you have, your job is to search what is the min term for that. You have to search what is the min term for that. So we will do that. It is 8, 11, 12, 14. I will mark it also so that you understand from where I am writing all this. Okay. So 8. First of all, for KA, 8 is, I will mark simply once. This is 1, 1, 1. And it is good if you mark for your exam also, because so many things are there, na, you may get confused. So this is 1, 1 is there and this 1, 1 is there. So these blue colors are showing these 4 ones. So what is this? Double 1, double 0. What is double 1, double 0? It's a 12. Okay. Then what is this one? 1, 0, 1, triple 0. 1, triple
Ma'am,
0 is
doubt, ma'am.
nothing. Tell me.
Shouldn't there be Z also in the equation you wrote over there? JA, KB,
Yes, yes, yes. Z will also be
JA,
there.
JB, KB, and Z also, right?
Yes, yes. Z is also there. Z is also there. Okay. Now, so now let us complete our don't care of KA. So what is don't care of KA? Big list is there. I will write the answer. You can verify it at a later time. Okay. It is 5, 6, 7. Okay. So this is your KA. Now you have to see your JB. Now I want any one of you to tell me JB. How many ones are there? Don't care, I will write at least once, you tell me.
Only two ones, ma'am.
Yes. So what is that?
Ma'am, it is 3 and
2.
yes, ma'am, 3 and 2, ma'am.
Okay, am I connected now?
Yes, ma'am.
Yeah, so can you see I have completed JA, KA, JB, KB. Now again, for equation of JA, KA, JB, KB, you need to make K map for that, right? So K maps for JA, KA, JB, KB, I am not making here. You people are good enough to make. That comes in your first module only. But for your reference, I will give the answer. Okay. So JA is FBY. Okay. Then KA is little big one. KA is little big one. It is X bar Y bar plus FB Y bar. So you can verify this answer. Okay. But you please do not leave it. You have to complete this. This is required for your practice and to make it to get the answer fast. Okay. Because students know it, because they do not practice, they struggle in the exam time. You know that our examination system requires you to do things fast also. So this is your 4 equations of the input of the flip-flop. This is the 4 equation of the input of the flip-flop. Okay. So JAKA, JBKB I got. For X, you all know there is, sorry, not X, Z. Z remains same as it was before, and you remember that it is FA, FB
FB
dash.
bar XY.
Correct. So there is no change in Z, only input equation changes. Now what will happen? You have to simply draw your 2 flip-flop and show these connections. You can do that, or do you want me to show that also?
We can do that, ma'am.
Okay, so you have to make your 2 flip-flops, show all the connection. If there is a problem in showing connecting wire feedback and all, you simply show your and or gates and write those variable. Examiner will understand from where you are doing this. But please do not miss to make clock of flip-flop and the 2 input and 2 output, and your Z should be made properly because that is only 1 output. Okay. So this is how you do the same state machine question using JK flip-flop.